Today's lesson is on inequalities involving absolute value. Very similar to equations. If you take this, for example, I just got a couple equations up here. Normally when you had this as an equation, so this was an equal sign, you wrote it as two separate equations. You had m plus 2 equals 11 and m plus 2 equals a negative 11. Well, the two cases really say that inside your absolute value, you really have a negative case. So when you divide this side by negative 1 to get rid of that negative, this is why you have m plus 2 equals negative 11. That's why you have the two different equations like this. Today, when you deal with inequalities, you cannot just change this 11 here to negative 11. You actually have to take this process. Reason why is you have an inequality sign, and when you divide by that negative number, such as a negative 1, your inequality sign is going to flip. So again, with example 1 here, you're going to go ahead and write it out and get rid of your absolute value. So do your two cases. So you will have m plus 2 is less than 11. That is your positive case. Now here is your negative case. So you have a negative inside your square root. M plus 2 is less than 11. Now you need to go ahead and solve for m as you normally would. So subtract by 2 on both sides, and you have m is less than 9. If you look at the second example, you have to get rid of that. This negative sign is being distributed. Two ways you can do it. You can actually distribute the negative sign and solve, or you can get rid of the negative sign by this negative is multiplying, so I'm going to divide this by negative 1. When you divide by negative 1, your inequality sign will switch. Now you get rid of those negatives, and you have m plus 2 is greater than negative 11. So we subtract 2 from both sides. After you subtract 2 from both sides, you have m is greater than negative 13. Your next step is to go ahead and graph this. So we'll go ahead and graph here. Like you did yesterday, we need to get up to 9 and negative 13 here. So here's our number line. Let's go ahead and graph. This says m is less than 9. So on 9, you'd have an open circle, and m is less than, so it would be these values to the left. Over here we have m is greater than negative 13. Open circle on negative 13. Here's the values that are greater than negative 13. So this is showing that union and that range there of values for the absolute value for this inequality. Example 2, absolute value is isolated. So let's go ahead and make our two cases. Here's our two cases, the positive case in red and the negative case in blue. So I'm going to go ahead and work through this by subtracting 6 from both sides. We have 3n is greater than or equal to 6. Divide both sides by 3. And we have n is greater than or equal to 2. Second one, remember what we did last time is we got rid of the negative by dividing because that negative is being distributed into that. Another way you could go ahead and solve this is actually distribute the negative, and I'll try this approach here. So we have negative 3n and a negative 6, which is greater than or equal to 12. We're going to add 6 to both sides. We get negative 3n is greater than or equal to 18. Divide by negative 3. When you divide by negative 3, your inequality is going to flip. So we have n is less than or equal to negative 6. So if we look at our values, negative 6 and 2, we need to hit on that number line. We look at this first inequality. We have n is greater than or equal to 2. So on 2, you'd have a closed circle. That value would be to the right. Here's all the values where n is greater than or equal to. Second inequality, you have n is less than or equal to negative 6. Here's negative 6. Here's the values that would be less than or equal to negative 6. Example 3 is slightly different only because we have to isolate the absolute value here. In order to do that, we would actually subtract by 4 on both sides, get rid of that 4. You now have absolute value of 4p plus 2 is greater than 6. Now that is isolated. We can break it into our two cases. The positive case of 4p plus 2 is greater than 6, and the negative case we have is 4p plus 2 is greater than 6. Now again, you can determine for the negative piece if you want to go ahead and distribute the negative or divide the negative out. And I like to go ahead and divide the negative out right away. Flip the inequality sign, and we have 4p plus 2, because these negatives would cancel, is less than negative 6. And now we can go ahead and both these equations we could go ahead and solve for p. On the positive side, we're looking at subtracting 2 to both sides. So we have 4p is greater than 4, and we would divide both sides by 4, finding out that p is greater than 1. The negative one, after we have got rid of that negative piece component to it, we're going to subtract 2 from both sides. We have 4p is less than negative 8, and divide both sides here by 4, and we have p is less than negative 2. Now we could go ahead and graph here. Notice that we need to hit 1 and negative 2 on that graph. The first piece of the inequality, we have p is greater than 1, so at 1 we'd have an open circle. P is greater than 1, that would be the values to the right. The next component, we have p is less than negative 2. Here's negative 2. Open circle on negative 2. The values for less than negative 2 would be to the left. So there's our inequality graphed. On to the last example here. So first off, let's go ahead and isolate the absolute value. Doing so, we'd subtract 6 from both sides. We have a negative absolute value, 2h minus 3. Absolute value is greater than, well, 9 take away 6 gives us 3. Absolute value is still not isolated. We have that negative. Well, let's get rid of the negative. Well, let's divide it by negative 1. When you divide by a negative number, inequality flips. You now have the absolute value of 2h minus 3 is less than negative 3. Second piece of this, go ahead and break it down into the two cases, the positive case and the negative case. Positive case here. The negative case, where we have the negative on the outside set of what's inside the absolute value here. And I'm going to have you go ahead, pause the video. Why don't you work through this, figure out what your two inequalities look like. The positive component, I added 3 to both sides, and I had 2h is less than 0. Get rid of 2 by dividing, and we have h is less than 0. The negative aspect, I went ahead and distributed this time. Just I was hoping that you divided by negative 1. I'm going to prove to you that it really doesn't matter. So we distributed, we get negative 2h plus 3 is less than negative 3. Subtract 3 from both sides, we have negative 2h is less than negative 6. And then the final step here would be to go ahead and divide by negative 2. When you do that, remember inequality would flip, and we have h is greater than 3. And then the last piece here would be to go ahead and graph. Reminder on the graph there, you need to use 0 and 3. So on h is less than 0, well, here's 0. 0 would have an open circle. The value that would work for h would be the values to the left of 0. And we have h is greater than 3. So on 3, again, open circle. The values that would be greater than 3 would be the values to the right. This will conclude absolute value inequalities.